Hello and welcome to this video brought to you by Smart Edu Hub Mumbai. Today's topic is photochemical reactions of alkanes. Alkanes generally are highly unreactive, but they react with halogens only under special conditions. And what are the conditions? Well, it's like you take an alkane and you put it in a sealed tube. So suppose this is my alkane and I have put that in a sealed tube along with some halogens, say chlorine, and I expose that test tube to the bright sunlight or any other UV light. What I will find is I will find that gradually all the hydrogen atoms of the alkane get substituted one by the halogen atom, and this keeps happening till each and every hydrogen atom is replaced. So now you will get products which are called as halogenoalkanes. I'll explain what I mean by this, and you will also get hydrogen chloride gas. Okay, so basically because this reaction is triggered by light, it is said to be a photochemical reaction, and because each time one hydrogen atom gets replaced or substituted by a halogen atom, this is also sometimes said to be a substitution reaction. Okay, so now let's see what exactly happens in photochemical reactions of alkanes. So now suppose there is this bright sunlight and we have in our test tube the alkane, which is the methane. So we are going to take the methane and react the methane with a halogen such as Cl2. Now, like I told you, each time one chlorine atom of the diatomic chlorine is going to replace one hydrogen atom of the alkane. So in this case, what I mean is, instead of CH4, if one hydrogen gets replaced, we will be left with CH3, and instead of the hydrogen, now who's taken the place? A chlorine atom has taken the place. So we will get something like CH3Cl, and then the hydrogen that got knocked out from here will combine with this chlorine here to form something called as hydrogen chloride. So what's going to happen in short? The reaction will be CH4 plus Cl2 gives CH3Cl plus HCl. And remember, all of them are gases. So do not forget to write gas below or next to it. So after this, what happens? Reaction stop. Is it over? No. Now this CH3Cl that is formed in the product side, that's going to get into further reactions. So you have CH3Cl. So this CH3Cl will enter into more reactions with Cl2. Again the same thing will happen. This Cl2 has got two chlorines. One chlorine will go and knock out one hydrogen from CH3Cl, and therefore what will happen is, instead of CH3Cl, the new product will be one hydrogen less, so it will be CH2, and one chlorine more, so it will be CH2Cl2, and again HCl will be formed. So what's going to happen again? I have one more hydrogen getting substituted. So again the states will be gases. Okay, now we need to know how to name them. Okay, so now this product here, the first product that is formed here, is called as chloromethane. Remember, it's a derivative of methane. Now this here has got two chlorine atoms in it, so it is called as dichloromethane. And what happens? Now this dichloromethane, CH2 Cl2 will react with more chlorine, and what will you get? Again, these chlorines are diatomic. There will be two chlorine atoms. One chlorine will go and knock out one hydrogen. So what is going to happen is, instead of CH2 we have CH, and instead of Cl2 we have Cl3. That means again the hydrogen got decreased by 1 and chlorine got increased by 1. Again you have HCl. Now how many of chlorine are there in the new product? There are 3. So this is trichloromethane plus hydrogen chloride gas. And remember, all of these are gases. Do not forget to write these states. And further on, what happens is, this CHCl3, which is a gas, further reacts with more Cl2 again, which is a gas, and again diatomic chlorine is going to react in such a way that one chlorine atom is going to knock out the last available hydrogen, and the new product will be C. Instead of H, now we have one more Cl, so the product will be CCl4 plus HCl. In this case, remember, it is a gas, and again you have hydrogen chloride gas also. The name of the new product will be tetrachloromethane. So now this is basically what happens in substitution reactions of alkanes or halogenation of alkanes, or you may call it as the photochemical reaction of alkanes. Remember the special condition: sunlight is needed to trigger the reaction. The reaction cannot take place on its own, and therefore the reaction is said to be a photochemical reaction or a substitution reaction. So this is all in today's video on photochemical reactions of alkanes. I hope you like watching my video. Please do subscribe to my channel if you like. Okay, before I end my video, I would like to tell you one more important thing, that I have told you it's a photochemical reaction for alkanes. I have never said that it's a photochemical reaction for methane, or it is only a photochemical reaction for chlorine. So basically you can take any alkane and you can react that alkane with any halogen, and the product is going to be a halogenoalkane plus hydrogen bonded to one halogen atom. Okay, so this is the general reaction. So thank you for watching my video. Please do subscribe if you like.